My name is Giancarlo Cravotto. I am full professor at the University of Turin, one of the oldest European universities. We celebrate a few years ago the 6th century from the foundation in 1404. Our department is the Department of Drug Science and Technology. We are the group of organic chemistry, and within our department we are developing new technology suitable for lab scale as well as in a bigger scale with pilot reactor. We are working with different types of technology, and we are able to compare the effect in the promoting chemical reaction, in the degradation of pollutant, in processing, and any other kind of industrial application. We are working in batch reactor as well as in flow reactor, and the main technology is microwave. Since the first application of microwave technology in promoting chemical reaction in the 1986, a huge number of papers and patents and review show how this technology is largely exploited in the university, in academic, as well as also in drug discovery and many other fields of application. The advantage is related to the volumetric heating and the specific absorption that particular material are presenting to microwave. One fantastic application is in the field of nanomaterial. In particular, carbon-derived material, carbon nanotubes, graphene. In the last few years, an enormous increase of papers are dealing with such specific application. No other technology would enable the grafting of such material that are extremely useful in a number of applications, ranging from medical application, diagnostic, electronics, and material for automotive and many other fields. New material have been created not only in milligram scale, but really in multigram scale for a wide range of applications. Microwave are one of the most attractive and most promising technology, both in lab scale and also in pilot and very big scale. With the new type of reactor, we can perform in parallel different type of reaction, changing the solvent, changing the catalyst, with an optimization that can be carried out without one day. So the optimization up to the lead product in a very short time. Due to the collaboration with some big company, we are able to develop new catalysts thanks to this kind of technology, mainly microwave, but as well as with the combination of microwave with ultrasound or hydrodynamic cavitation. The new catalyst can then perform and behave much better than the original one in developing also new type of green catalyst. In one lab, you can also have a little factory in which you can optimize the reaction in milligram scale, and then within one day you can produce multi-gram of your target compound. There are not so many other technologies that so fast can accelerate, can promote a chemical reaction. In the same time, you can mix different phases in a very homogeneous way due to the new system of irradiation. This accelerates so much, and you create the condition to create new bonds or to break bonds. My experience in organic synthesis started in the synthesis of natural product, but using normally in the end of the 80s and in the 90s, aggressive reagent and environmental unfriendly solvents. Moving to microwave, we can in any case accelerate the reaction and promote chemical reaction, otherwise extremely slow, thanks to the strong heating and selective heating. This means that it's the best way to move organic synthesis from traditional synthesis to green chemistry. Drug discovery is perhaps the most common example, in which you have to create a chemical decoration of your scaffold With the new type of microwave reactor, in the same time, you can, in a parallel way, you can generate, you can synthesize different type of new product. In 10 years, we move from this old technology to the microwave reactor. Actually, I started, as most of the people, by heating with a domestic reactor, domestic oven. Then, due to the safety, immediately we moved to professional reactor. Reactor in which you can insert gas, in which you can work under pressure, in which you can also reduce the pressure, and you can even evaporate. This is a big advantage. In only one tool, in only one facility, you can perform all the steps that in an all-organic lab was in a different step. So reaction, filtration, evaporation, and so on. So this is extremely fast and extremely clean, and in the same time, in most of these reactors, you can have a scaling up to multi-gram scale to prepare your product in the optimized condition that you selected within 1 day of work. I would say, beside organic synthesis that has much exploited microwave in the last 20 years, inorganic chemistry, material, have a huge growth of application, and new material have been created under such condition. Extraction and reaction in a heterogeneous phase have had a huge evolution and a huge improvement thanks to microwave irradiation. Green chemistry, you cannot imagine to work in this field without microwave due to the fast depolymerization of biopolymers, for the valorization of biomass, for the synthesis of new catalysts, for the preparation of new nanomaterial. At the beginning, 15 years ago, in a meeting, often I heard microwave are a good toy for academic to play around, to perform reaction in a different way and not creating a new chemistry. This is absolutely wrong. Now microwave are definitively an irreplaceable tool for chemistry, all field of chemistry, ranging from organic chemistry, inorganic chemistry, environmental chemistry, pharmaceutical chemistry, even in certain field of biology. Reactions are fast, are efficient, are repeatable, and without aggressive, harsh reagent. So green chemistry can obtain the best advantage from microwave. Often we discuss with students, with PhD students, why to perform a reaction in microwave. Microwave changed the way to work in our laboratory.